Hello there and welcome. Today we are going to discuss a very interesting design pattern called the command design pattern. Here is the Wikipedia definition. Don't worry if you do not understand this definition. There's a lot to chew here, so I'm just going to skip this slide for the time being and come back to it later. But essentially, a command pattern enables a client object to encapsulate any message or any method call that it sends to a server object as an object. So every request becomes an object. All the information that is required for that request to be executed is included in the command object, and these command objects are executed by another object called the invoker later. So let's see this as an example of human communication. Here is a person who wants to send a request to someone. This is the person who is going to process the request and send a response. The interaction is simple. The client sends a request and the server responds. So in terms of two human beings interacting to get something done, this becomes a client-server interaction. How about we introduce the command pattern paradigm in this human interaction? So here is the person who wants to send a message. What they do is they build a collection of all the messages as a collection of objects. In this example, maybe they note it down and they have a collection of documents. They hand it over to someone who in turn hand it over to the person that processes those commands. And once they are done, the interaction is complete. So in our example, we just saw introduction of an object in the middle. Well, that's a human being, so I cannot call them object, but that's the invoker person that is sitting in between the client and the receiver. But every possible request to the receiver is encapsulated in that stack of paper, which is a collection of commands. And then the invoker hands over the information to the receiver. The receiver knows how to process those commands, so they will go through that stack of paper and do whatever they are supposed to do. So this is the command pattern implementation in terms of human interaction. So in a nutshell, the client object, instead of sending messages directly to the server object, and now we are talking about object-oriented systems, the client object creates commands and receivers. The receiver is the object that is going to eventually process these commands, but the interaction is not direct. The client object first creates these commands and then assigns receivers to it. The invoker invokes these commands. So that's the guy in the middle. The receiver knows how to process a command. We are going to implement command pattern on a message logging framework. Here is the example. We have a client object that can request a number of receivers to record or log messages. Who are those receivers? File log, which represents a file, and a database log, which represents a table in a relational database that can record string messages. The commands that we are going to use for our example are log message to file command, which is self-explanatory, essentially logs a message to a file. Log message to database command, which is the second object, does the same thing, but this time to the database log object or the database log receiver. Both these that are listed above are concrete commands, and they implement iLogMessage command abstract class. And finally, the client program, which is the program.cs main method. So this is going to be a C# console application with a main method, which will act like a client and request message logging. This is the class diagram. So On the left hand side, we have a logger framework, which is going to be the invoker. This is the guy that will hold all the commands to log messages, and this is the one that's going to execute them. On the left hand bottom, we have the client class, which is going to create all the commands. So the right hand side on the top, we have the abstract command, which is a C# interface ilog message command, which just has one method called log message. And that's implemented by the two concrete commands, log message to file command and log message to database command. Each of these commands will hold reference to the sink or where the message will be logged. So log message to file command will have the file log as its attribute, and log message to database command will have a database pointer with a connection string and all the details to log messages to a table in a relational database. Let's move on to the demo. Let's take a look at the source code for our demo. So I have in Visual Studio a solution called the command pattern solution, which has a console application called command pattern console application. So let's go through the code. The first thing we have here is the log message command, or the ilog message command, which is the main contract or the abstract command. It has just a solitary method called log message. This interface is implemented by two concrete commands. The first command is called log message to file command, and that holds a reference to a file log, which we will visit in a second, and then the string message, which is the message to be logged. When this command is created, we get the file log and the message included or passed into its constructor, and then later on it logs the message to the file. The other concrete command is the log message to database command, which receives a database log, the receiver, which we will visit in a second, and then the string message, and then from its constructor it gets the database log and the message included or created or set in the command, and in the log message it just writes the dblog log message. So now let's take a look at the two receivers. File log implements the log message method. It reads the file path from application settings, and then it writes to the file whichever message was sent to it and set on this object. So file log just represents a file in an operating system, in our case Windows, and this is implemented as a singleton design pattern because typically you would log to just one file. Database log object represents a database log table, and essentially this also does something very similar, but the difference here is it knows how to write a message to a database table. This is not implemented completely because I do not have access to the database right now, but pretty much the command is create a SQL connection, create a command, execute a stored procedure to log the message, and then close the connection. So in our example, we have ilog message abstract command, log message to file command, which is one concrete command. Another concrete command is log message to database. File log and database log that are the sinks of our message. They are receivers. And finally, we have the program.cs class, which creates these two concrete commands here and then adds those to a list. And then we have the logger framework, which is the invoker class. It gets all the commands, and then all the framework or the invoker does is calls log message. And let's take a look at the logging framework finally, and just has a list of ilog message commands. Notice that the logger framework does not know concrete commands. All it knows is it holds a collection of commands which it gets through its constructor, and then it processes those one by one. As simple as that. So the idea here is when a command gets created, so let's go back to the command, it gets its receiver and its message via its constructor, and those things are set on the command itself. And then once the invoker gets these commands and the client calls log message on the invoker, it just executes these commands. Each command knows its receiver and the message to log, and that's how it works. So now we are ready to execute our code. So notice this is the client main method. What it's doing is it's creating a new command to log message to a file. So as we step into this code, through the constructor, the file log, which is the receiver, and the message are being set on the command, and the command is created. Now the same thing is done for the database log command. The database log, DB log receiver, and the message are getting set. Now that we got our command object set, we create a local list of commands and add these two newly created commands to that list. Now we create the invoker and pass to it all the commands. And the last step is to call the main method to request the invoker to execute all the commands. So as the commands get executed, you will notice here's the first command getting executed. All it's doing is it's calling receiver, which is the file log.log message, which writes to a file. The invoker moves on to the next command, which is the database command, and the database command invokes log message method on the receiver, which is the database log here. And this code is not complete, but essentially it knows the API to how to write to a database table, and this is the database log receiver. And notice after this execution is done that in the logger framework, which is the invoker, it has no knowledge of any of these concrete commands. It just knows that it has a collection of ilog message command, which is the abstract command. And once it's done with everything, the response goes back. And let's see our log file. In our log file, we have a message. Now, if we wanted to add more syncs to our solution, that is an XML file or Microsoft message queue or a web service to log messages, all we had to do was add those commands, change our client to create those commands, and then set those on the invoker, and then the invoker will be able to execute these. The invoker would not know how these log message commands are executed. Now that we have seen a demo of the implementation of the command pattern with the help of a logging framework, let's discuss a few features of the command objects. First of all, each request is a command object. It's all encapsulated in an object. Each command object knows who its receiver is. So the command to log message to a file has a pointer to a file object, and the command that writes to a database has a pointer to a database log that represents a table in a relational database. Each command object either knows or can derive the data needed to execute it. So in our example, when we created these commands, each command knows the message it's supposed to log. So a command object is self-contained in that sense. Once again, all the commands provide a uniform interface to the invoker, which allows the invoker to be decoupled from the concrete commands. The invoker knows that it has a collection of abstract commands and it just executes them via a common interface. Let's discuss features of the invoker object. Invoker can execute commands one by one in a collection of commands without worrying about details of what each command does, because the invoker is coupled to the interface, the abstract command, which each concrete command implements. It just has to execute abstract commands, common interface, and not worry about what each command does. Here is one big advantage of using command pattern. The invoker can process commands as a transaction. So let's assume each of these commands executed an execute and an undo command. Then the invoker could process these commands as a transaction. That means as it's invoking these commands, if the invoker encounters an exception, it could undo all the commands that were already executed. So this will be an all or nothing atomic transactional procedure. Another advantage with invoker is the invoker works like a command queue. So you build your commands and then you send those to a queue to be processed later. Once the commands are sent to the invoker, the client does not have to wait for their execution. So one-way command pattern is advantageous to the client is the fire and forget paradigm, in which the client sends these commands to an invoker or to a message queue and does not have to wait for all these commands to be executed. The client can do something else and the invoker either immediately or maybe at a later point in time can execute these commands. The receiver object knows how to process a command. So in our example, the database log object knows how to write to a database table using ADO.NET code, or the file log object knows how to write to a file using .NET's File Input Output API. So let's discuss a few advantages of using the command design pattern. As we can see, the commands can be executed immediately or later. So the creation of a request, which is essentially a command, and the execution of the command are independent of each other. With command design pattern, you can build collection of commands. So in our example, there was a collection that wrote to a file and to a database table, and those two commands executed together, almost like a macro. And these commands can be executed immediately or later. Command design pattern enables us to use an extensible model because more commands can be added later without changing the invoker. So in our example, if we wanted to also log messages to an XML file or MSMQ, we will be creating two new commands for writing those messages to XML file and MSMQ respectively, and then we would just execute these guys as a collection within the invoker. So the invoker won't even know that it got something related to an XML file now or MSMQ. It will just get these commands and it will execute them. The client has to do that extra work of creating these commands and sending those to the invoker. The client and the invoker are typically decoupled. So in my example, in the code, the client creates the invoker and executes commands on it. But essentially in command design pattern, if you look at most of the resources, there is no coupling between the client and the invoker, because the idea is that the client creates and saves commands in a queue and the invoker reads commands from the queue, maybe later or maybe immediately, and then it executes those. So the client and invoker are typically not related or not coupled. Few more advantages, or maybe summarizing those advantages. Message queuing. So you can send commands to a queue to be executed later. So in a message queuing framework, command pattern would come in handy. Transactional support. If each of these commands exposed an undo operation via the common interface. All these commands could be executed in one transaction. So as I mentioned earlier, if the invoker encounters an exception while executing any command, it could call undo on all the commands that were executed already. So this would be like an all or nothing kind of transactional approach. That's the same example with undo operation. So the key takeaway from command pattern is that it decouples creation of a request from its execution. Let's see if we can understand the command pattern now. This is the command pattern definition revisited. So command pattern is a behavioral pattern because it's related to behavior of objects, and an object here is used to encapsulate information needed to perform an action or trigger an event at a later time, which means all the information that is needed to execute an action is included in command objects, and that can be executed at a later time. And each command object includes the method name, the object that owns the method, and the values for method parameters. So in our example, the method parameter here is going to be the message to be logged, and that is encapsulated in the command object itself. And all the information included in the command object makes the command object independent and self-contained. Hope you like this video. Your feedback is always appreciated, and I hope to see you in another video. Thank you.